Okay, I'm going to go over some bonding examples, and these will just be basically, these won't be expanded octets. These will just be the normal version using my method. It's slightly different than dot method. So, all right, the key thing here is that, so we're going over bonding structures. And these are the ones I already did in the previous slide talking about bonding, and I'm going to go over to these guys here. Now here's the key thing between all of these is that let me put these in here first of all. Okay, so the key thing is that when you have a chemical structure, you come up with a skeletal structure. Okay, put the lone atom in the middle. Okay, so let's say this is a lone atom right here, and that guy will have the lowest electronegativity. Examples also is carbon, it will usually be in the middle. Hydrogens will never be in the middle. And then the outside atoms are the more like higher electronegativity. Okay, and that's key point. So when you get the skeletal structure, the atoms on the outside will get number of lone pairs and bonds that the second row element usually gets. Okay, so that's over here in the column. So so if you have hydrogen always gets one bond, has no lone pairs. Carbon and anything in its column will have 4 bonds and no lone pairs if it's on the outside. That's usually the case when it gets in the inside, but it doesn't have to. Nitrogen and anything under it, like phosphorus, will have 3 bonds and 1 lone pair if it's on the outside again. Oxygen and elements under it, like sulfur and beryllium, will have 2 bonds, 2 lone pairs, and on the outside. And fluorine and elements under it will get 1 bond and 3 lone pairs. So that, and then what you do is you count up number of dots, and if there's dots missing, you put them in the middle. So let's go over these quickly and efficiently. All right, so first one is HBr, hydrobromic acid. Figure out how many valence electrons it has. So hydrogen plus bromine is 1 plus 7 equals 8. And then you draw the skeletal structure. Now it doesn't matter who you consider in the middle. In this case, I'm going to say hydrogen's in the middle. I mean, bromine's in the middle, and hydrogen's on the outside. And one thing is it has a slightly higher electronegativity. Hydrogen does, so let's give it the number of bonds. So give hydrogen 1 bond. Okay, now count how many bonds you have in your structure. Well, you have 2. How many left over? 6. You need 6 more, and so 6 go on the outside atom. All right, there you go. Count them up: 2, 4, 6, 8. And now, if you notice, is that bromine's in the same column as fluorine, and it should usually have, not should, but usually have 3 pairs and 1 lone pair, 1 bond. All right, O2, sorry about that. Count the number of valence electrons. There's 6 for both oxygen. Skeletal structure, doesn't matter which one you consider the outside atom. So I'll pick this guy right here, and I'll give it 2 bonds, 2 lone pairs. So that's what I said about oxygen. It'd be silly to pick this version of oxygen because it's only connected to one thing. So the double bond is the right one. So count number of dots: 2, 4, 6, 8. You need 4 more. So put a bond, and you're done. And if you notice, both oxygens have 8 electrons in their outer shell, which you expect, and also 2 bonds, 2 lone pairs. The second row elements. Okay, N2, same thing. It's in the 15th column. There's 5 valence electrons. All right, skeletal. Pick one of the atoms to give 3 bonds and 1 lone pair. That's what nitrogen usually gets. Again, the triple bond connects. It has a 1 connectivity. Count number of dots: 2, 4, 6, 8. you're short 2, put them on this end, and you're done. If you notice, each nitrogen has 3 bonds and 1 lone pair, and 8 electrons in the outer shell. 2, 4, 6, 8. Okay. Okay, fluorine. Again, count them electrons, 7 plus 7 is 14, skeletal structure. I'm going to pick this guy to give 1 bond and 3 lone pairs, count them up. Need 6, there's 8, you need 6 more because you need 14, so put the other 3 here. And again, you notice this is what you expect. Alright, silicon tetrahydride. Okay. Number of bonds, number of valence electrons, so it's going to be 4 from silicon and 4 from hydrogen, so you need 8 altogether. Here's skeletal structure. Okay, hydrogen's on the outside, so we give it its normal number of bonds and pairs, so it gets 1 bond, each one. Count number of dots, each dash is worth 2, so 2, 4, 6, 8. And you're done. Right. Alright, carbon tetrafluoride. Okay, carbon has 4 electrons, valence electrons. Fluorine has 7. 4 times 7 is 32. Okay, let's make sure fluorine gets 1 bond and 3 lone pairs. So that's what you get here. Count the number of dots. 2, 4, 6, 8 around each for each fluorine. So it's 4 times 8, which is 32. And that's same as here, so this is the correct structure. Okay, this is called hydrogen sulfide. Count number of valence electrons. There's 2 hydrogens, so and 1 sulfur, so it's 2 plus 6 gives me 8. Here's skeletal structure. Put sulfur in the middle, hydrogen on the outside. Give the outside atom its number of bonds and lone pairs. So hydrogen only gets 1 bond. Number of dots, 2, 4. You need 4 more, so the other 4 goes 2 pairs on the middle atom, and you can see that's what we kind of expect because sulfur is in the same column as oxygen, which has 2 bonds and 2 lone pairs. Now it doesn't have to be this case. Okay, sulfur could have doesn't need to have 8 electrons around it. It can sometimes expand to 12, 10, or 12. Okay, so in this case it follows the oxygen. Okay, alright, COCl2, let's count the valence electrons. So there's 4 from carbon, 6 from oxygen, so that's 10. Each chloride is 7, so that's 2 times 7 is 14, equals 24. Okay, there are 2 lone atoms, okay. You want to put the most electronegative atoms on the outside, so oxygen is more electronegative than carbon. So put carbon in the middle. Okay, now what we're going to do is give this outside atoms their number of lone pairs and bonds. So oxygen gets 2 bonds, 2 lone pairs. Okay, each chlorine gets 1 bond and 3 lone pairs, just like fluorine, so it's behaving like fluorine. Okay, now count everything up. We get 2, so it's down here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Same as up here. And so this is the right structure. Okay, the shape of this guy. So the previous one, I forgot to talk about this one. Let's just talk about its shape and polarity. Okay. So this guy in the previous example, this is bent. There's 2. So the center atom has 2 bonds, 2 lone pairs. So this is bent. All right. The hybrid would be. It has 4 things attached to the center atom. There's 2 bonds and 2 lone pairs, so this would be sp3. And this is a polar molecule because it has different things attached to the center atom. It has bonds and lone pairs. Okay, the other ones like oxygen and nitrogen, those were both, we really don't have a name for that. I guess you call them linear. They're both nonpolar. All right. As far as this one goes, it has, this is going to be, it has, center atom has 3 attachments, so it's going to be trigonoplanar. All right, just write it as TPL. The hybrid is sp2. Okay, this is a polar molecule as well because the carbon has different things attached to it. Okay, PBr3. So phosphorus has 5 electrons, bromine has 7, so it's 5 plus 21, 26. Skeletal structure. Give the bromine, it's on the outside, give it the its number of bonds and lone pairs, which is the same as fluorine. So it looks like this. Count number of electrons. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We need 2 more. Put them on the middle. Here you go. Okay. All right. The shape. This is going to be trigonopyramidal because the center atom has a lone pair. So 3 bonds, 1 lone pair. So trigonopyramidal. Okay. The hybrid is sp3. 4 attachments. And this is a polar molecule because it has 2 different things, at least 2 different things attached to the center atom. It has a bond, bromine bonds, and lone pairs. Okay, HNO. Okay, count number of electrons. 5 from nitrogen, 6 from oxygen, and 1 from hydrogen, so 12. Okay, what's the structure? Hydrogen always goes on the outside. Oxygen is more electronegative than nitrogen, so put it on the outside. Okay, give the outside atoms the number of bonds and lone pairs. So hydrogen gets 1 bond. The oxygen gets 2 bonds and lone pairs. Count all the dots. 2, 4, 6, 8, 10. We're short 2. Put the 2 in the middle, and there you go. All right. Okay, this shape is going to be bent. Okay, it has 2 bonds and 1 lone pair. This is going to be sp2 bent, okay, because it has 3 attachments. If it had like water, has 2 lone pairs and it's bent, but it has 4 attachments, okay. And so those, it's a sp3. This only has 3 attached. 1, 2, 3. Remember, also, yeah, okay. And we could talk more about these double bonds as well. This double bond is one of is a sigma, and the other one's pi. And both these sigmas are sp2 hybrids. All right. Okay, this is a polar molecule because this nitrogen has different things attached to it. It has an oxygen, hydrogen, and a lone pair. Okay, SCl2. Okay, by the way, going back to this guy right here. Okay, a couple slides ago, that has the same makeup as water. All right, the PBr3 looks very similar to ammonia. Okay, so there's going to be commons. So once you kind of know the common structures, you can figure other guys out. You can make sure that you're right. We'll see how this one relates to it as well. Okay, so sulfur has 6 in Chlorine has 7, so 6 plus 14, 20. Okay, give chlorine its number of bonds and lone pairs. 1 bond and 3 lone pairs. Count number of dots. 2, 4, 6, 8, 10, 12, 14, 16. Okay, we need 4 more, so we're going to put the 2 in the middle. Okay, now if you look at this structure, it actually looks quite a bit like this one right here. Okay, because it has this, like waters was H. Okay, center atom had 2 bonds, 2 lone pairs. So a lot of the same properties that this will have, same as water. So this is bent because it has 2 bonds, 2 lone pairs. It's sp3 because it has 4 attachments. So the bonds are, these are both sigmas. Okay, all single bonds are sigmas. And this is polar. Okay. It's polar because it has, sulfur has both lone pairs and bonds attached to it. All right, H2. Okay, H2, 2 electrons. Remember, hydrogen's only has 1 electron and 1 s. Okay, so it can't have, doesn't, to say it follows the octet rule is just it doesn't make any sense because you can only have, the first energy level can only have 2 electrons. All right, so don't get caught up in it. That's one reason I picked this one, and so don't end up putting dots all over it. So give hydrogen 1 bond, count them up, you're done. Okay, I guess you could say this is linear. It's because it's straight across. And I guess you could say SP, and it's nonpolar. Okay, similar thing with Cl2. Just follow it through, pretty self-explanatory. Just like we did F2 earlier. All right, Si, S2. Okay, silicon has 4 electrons. It's in the same column as carbon. Each sulfur has 6, so it's be 4 plus 2 times 6, 16 valence electrons. Okay, put the silicon in the middle. Now give sulfur its number of bonds and lone pairs. It's in the same column as oxygen, so it's going to have 2 bonds, 2 lone pairs when it's on the outside. So that's what you get here. Now count up the dots. 2, 4, 6, 8, 10, 12, 14, 16. Done. Okay. This molecule has, so the silicon has just 2 attachments, so it's linear. Okay, all linears has sp hybrids. And this is a non-polar molecule because the silicon has the same things attached. It just has sulfurs.